In this video, I'm going to give you guys a walkthrough of the vegetables unit testing framework. I'm going to go through the basics of how to use it. We'll go through some details on how it works, some of the more advanced features, and even how to extend it a little bit. So let's dive in. So I'm going to start with basically a test of the testing framework itself. This kind of kills two birds with one stone, so to speak. So the first thing you'll want to need to understand is how do you put together a test? So in the most basic thing is a test is going to be a function that returns a result that kind of tells whether or not it passed, and it contains some more information, but the basic gist of it is a test is a function that takes no arguments, and the result is of type result, which is a type defined in the vegetables testing framework. So the simplest is a result, which we're using here to test whether the result type behaves properly, is a result can succeed or fail. So succeed is a function that takes a string, and fail is the same. They each take a string and they produce a result. Succeed is a passing result and fail is a failing result. And so that's the simplest way that you could possibly put together a test, is just have succeed or fail and return that as a result from your test. We're doing a little bit more in this test. My test is actually making sure that the results actually can tell whether or not they passed, which is where these assert that and assert not functions come in. Next, you can actually combine the assertions and the results made, and in order to return multiple assertions that you may have made in your test. So like this one, I'm creating a result that is the result of multiple assertions or tests. So I've just got two succeed functions, and you can put them together just with the AND operator. And then in this test specifically, I'm just making sure that that result can tell how many assertions were made, how many assertions were made when it was put together. Next, now that you kind of have a basic understanding of how you put together a test, how do you get those tests into the framework? And that comes from what I kind of call a spec function. You're going to use either the describe and it functions, or they're also given, when, and then functions. But they both kind of work the same way. Is it takes a string that is a description of what is this test kind of testing, or what is the specification that we're making here, and the name of one of the test functions that you put together. So for in this instance, this test suite here describes results, and it specifies that they can tell whether they passed, and then I specify the function that makes that test. And this puts together a test suite for actually running these tests. And so your spec function just returns a test item, which generally should be created from a describe function. And so the describe function takes a list of takes a string that describes basically what we're testing, and a list of test items, or an array of test items. And so what that's going to do is it's going to create a collection of tests, and each one of those is going to be run as part of that collection. And so this function will be run by the test framework to gather up all of the tests, and then it will run them once it's gathered them all together. So next, let's go through kind of how that build system works. if you're using the build system provided by either vegetable, you can use the build system provided by vegetables, or there's a standalone program that you can use to put together the driver routine if you want to do that manually, or you can do it manually. It's not that hard to do manually either. Basically, what it's going to put together is this driver routine. So it's I've just put all of the code into one subroutine called run. And basically what this subroutine does is it just takes all of the test files that it finds. So all of the files that it finds that end in underscore test, finds all of the functions that start with test underscore, and imports them with a new name just to make sure there are no name clashes. And basically just runs each of those functions that it finds to gather up all the tests into an array, puts them into a single collection of tests with the test that function, which just doesn't require a description, and then runs the tests with them. And there are some command line options that are available by using this driver program as well. The run tests function will call this get options function before it actually starts to run the test. And so you can kind of see here in this usage description what those options will be. If you just give it the -help, then this function will go ahead and exit, and it will print this usage message. It takes a quiet option, which says don't print the test descriptions before running the test. So if you don't need to see the whole list of test descriptions about what tests are going to be run beforehand, you can pass it the quiet flag. -V for verbose, which says to print all of the assertion messages, not just the failing ones. So even if a test passed, it will show you what are the values that it checked and how did those compare. You can give it a filter string, which will go through all of the test descriptions and only run tests whose description includes the string given on the command line. It's possible to run tests with randomly generated values, and there's an option to specify how many randomly generated values should it use for each of those. And then also the output ends up being colorized, but you can turn that off with the -color off option. And next I'm going to jump to another library that I've got to demonstrate one of the next features of vegetables. We'll get that opened up. And so you can see I'm using vegetables to test this library, and you'll notice that I've got some examples here. Right? So these number examples get passed to the it function, as well as the description and the test function itself. And what this does is this array of examples gets used and are passed one at a time to this check parse number function. Right? So it takes those list of examples and passes each one of those inputs one at a time into this function, into this test function, and combines all of the results together when it's done. So what an example is basically just a wrapper around an input. And an input is an abstract type that you will need to extend in order to create your own input types. So basically, in this example, I've got a number input which needs a string and a value, because that's what my test is going to need. But then I can create multiple examples that are going to be passed as input. And so what gets passed in is of class input. And so you'll need to do a select type to check that it did in fact pass the proper type, so that you can actually access things from your type. And then I can run some tests with it and get some results. And so it will run that same test multiple times with each one of those examples. And we can actually kind of see this happening. I'm going to copy that description string and run some specific tests. This is basically just a little convenient wrapper script that I put around compiling the tests and then running them with this filter, so that you don't have to do it in 2 steps manually, and it doesn't have to run the test before it runs it with the filter. Right. So this is going to run just that test, so you can see that it ran just that one test. But you can see that that one test got each of those things as an input, and so it reports each one of those results. And so that's a way that you can provide examples for your tests, so your test can take inputs. And so basically, any test that you want to be able to provide explicit examples for, you'll just need to extend this input type, which is just an abstract type that doesn't, nothing comes along with it. But it is just used as the base class for dealing with input values. So next, let's go ahead and jump back to vegetables, and we'll look at something that generates random values for your tests. So let's look at an example of that where I'm testing the assert doesn't include function. So the assert doesn't include function should fail if the strings are identical, because one would then include the other. So in that instance, any random string, I could use any random string to make this test, because I'm just going to pass the same string in for both arguments to that function. So this check fail for string function, again, takes as class input an example, and I'm going to make sure that that input is a string type, and then I can grab that example value, and I can then use that in my test. However, there's something a little bit more fancy going on here, in that I didn't pass it a list of examples. What I passed it here is actually a generator. This, which is an object of type generator, or of class generator, that will be used to generate random values, and if the test fails for any one of those values, has the capability of trying to find simpler values that still cause that test to fail, and then will report the simplest value causing a failure, instead of just whatever random value it happened to find to cause the failure. Because it will probably be easier for you to debug your test or debug your code if you've got simpler values that can demonstrate the cause of the failure. So the way that this works is let's look at an example of a generator that I've defined custom that isn't built in. The built-in ones are still defined the same way. They're just defined inside the vegetables testing framework. But you can, of course, create your own. So we'll look at this double precision generator that I created. So it's just a type that extends from generator, and it needs two type-bound procedures. It needs a generate function, which just takes the generator itself in as its first argument, and produces a generated type. And that generated type is just another wrapper around an input. So you can see that I've got type double precision input, which is just extended from the input type. So basically what I've done here is in the generate function we just generate a random value, and there are a handful of functions available within vegetables for use in generating random numbers, strings, etc. that you can make use of. In this case I'm going to generate a random double precision somewhere between minus 1e to the 12 and plus 1e to the 12. And then I'm just going to put that as the value for my input, and then I just call this generated function, which just takes a class input and just creates a generated t. So it's just a simple wrapper around that. And so what the framework will do is it will call this generated function however many times. I think the default is 100, but you can pass a different number on the command line to change how many it's going to use. So it's going to call this generate function that many times, and call your test with that input that many times. However, if one of those inputs causes it to fail, what it will do is it will take the input that caused it to fail and pass it to the shrink function of your generator, which just takes that class input as the input value, and you need to return a shrink result. And so a shrink result will be either the simplest value, so this is the simplest value that you can possibly make from this generator, or the shrunk value. So what it will do is it will continue to call this shrink function and then call your test with the result of the shrink function until it either gets the simplest value or the next shrunk value doesn't cause the test to fail. And then it will report whatever the simplest value that caused that test to fail. And if it gets to the simplest value, then that's the simplest value it can possibly get to, and so it will report that as the failure. And so in that way you can extend from the generator and create your own generators, which generate whatever types of inputs you need, so long as it knows how to generate them randomly and knows how to make them simpler in the case that your test fails. And the next feature that I want to talk about is the transformer functions. So in this example where I'm testing basically a test cases behavior, I'm going to use the given, when, then type of setup. And I'm going to say that in this instance, given can take an input, which is the case that I've made a test item input, which is the case that I'm going to want to test. And then when takes this run test function. Basically what it accepts is a function that goes from an input class, a class input value, to a transformed value, which is just a wrapper around another input. And so we'll go and look at this. This run test comes from this other helpers module. So this, as you can see, this run test just takes a class input. So you have to do a select type to make sure you get the type that you expected. We'll do whatever is necessary to transform that input into something else, and then takes that something else and just calls transformed to wrap it up into the transformed type. So it's just a wrapper around another type that extends from input. So the result here is a test result item input. So it's just another wrapper around an input. And so what will happen is before this collection runs each of these tests, it will take so what will happen is it will get that first input from the given collection. We'll get that first input, it will run it through this test, and then pass the resulting input from running it through this function to each of the test cases. And so what we've done here is we've created a test case, then we'll run it and then pass it to each of these functions to make some assertions about it. And so you see those functions again are just take a class input and still return a result. And one feature of the transforming tests that you can make use of is that if the transformed gets back a transformation failure, which is an extension from the input class, so that it can be passed back in this as a transformed value, but it will do a select type, and if it gets back a transformation failure, it will actually use that as the result, and it won't actually run all of your tests. So if something goes terribly wrong in your transformation function, you can actually report that result and report that as the failure rather than having to figure out what went wrong in all of your tests, because what went wrong wasn't in your tests, it was before those tests even ran. So you can actually short circuit running your tests if your transformation function manages to go wrong. And one of the last things we'll talk about is a performance testing. So in order to be able to test the performance of this, we need something that can run some code and time it and check how fast things run. So we've got an assert faster than function, which takes two subroutines, which don't take any inputs, which don't have any arguments to them, and it will just run one and run the other, and it will do that 100 times and compare how long each one took to run. And if the second one runs slower than the first one on average, given having run it the given number of times, then it will report that as a failure and report how long each one took to run. There are also combinations of the assert then function that take an explicit number or an explicit time for how long this should run within, and can also take some setup and teardown subroutines to maybe do some setup code that you don't want to be included in checking the runtime of what you're actually trying to test. So there's a variety of ways to kind of pare down and run just the code you're interested in trying to profile and make sure that it's running as fast as you want. And so that's the basic gist of all of the functionalities and features about how you would use vegetables as a testing framework. So next, let's just kind of run through the all of the functions that are made available for things that you would be using. The main ones are the assertion functions. And so those are basically just how you would check some various things about. Basically, those are just going to create the results of your tests. And there's a whole list of them. Assert where assert doesn't include, we'll check if one string includes another one. Assert empty makes sure that a string is empty. Assert equals can work for integers, strings, and double precision values. Assert equals within absolute or within relative give you a way of specifying the tolerance for comparing double precision values. Assert faster than allows you to profile and check the speed of certain functions. Assert includes checks whether a string does include another string. And then assert not and assert that just check the value of logical. The next major function are the describe and it functions, and the given, when, and then functions, which are used to put together your spec function and put your tests into collections. So that's about the gist of everything that you would need to be able to use vegetables. And some of these have a whole variety of interfaces so that you can call them with various numbers of arguments, various types, and stuff like that. So now let's kind of go through the types of vegetables, kind of go through how vegetables works. And we'll start with kind of the types and the hierarchy of the different types that vegetables makes use of. So some of the ones that are public that you might actually make use of, or that you would probably make use of, is this input type, which is just an abstract type, which is just to be used as a base class for being able to pass around values to be passed to the tests. It brings no features or functionality along with it. It's just a way for me to it's just a way for the framework to go, I've got values that I don't know anything about, but I still need to be able to pass them around. And so we've got a couple of examples of some things that have extended from input, so you don't have to create these ones yourself. I've created a few as kind of an example and just for convenience, because those would be in common use. Next are the transformed, example, and generated values. You won't need to extend from these. They just hold on to a class input. So these are just kind of what would be used in some of the more advanced features. So if you've got a transforming function in the middle between your inputs and actually the inputs that should go into the test, those will return one of these. Your examples are what are put into an array for actually having examples for your tests. And then generated is what you should wrap your inputs up in when they're passed back from your generator, when you're generating random values for your tests. And then the shrink result is what you should send back whenever if one of your tests fails and it tries to shrink or simplify the input that caused the test to fail, then the results from that shrink function should be a shrink result. But there are two functions which will generate this value for you, so you won't actually have to make use of the fact that it actually keeps track, or how it keeps track of whether it's a simplest value or not. Then we've got the generator, which is something that you will extend if you need to generate random values for your tests. I've got a couple here as examples, and which might be convenient, which just generate a random string or generate a random integer. So those could be used in your tests as well. So now we get to the part about tests, the tests themselves, and the basic building blocks of how the tests get combined into a collections. So we start with, at the very bottom, with this test T, which is a type that just contains a description. It's abstract, so there's no values of type test T actually floating around, but this is kind of the base of where we're starting. And so anything that derives from test has to have a description function, a filter function, num cases function, and run with input and run without input functions defined. And these are all deferred, so we don't have a general implementation of how these work for a basic test. We're going to have to define how those work later. And then the generic just run is just going to run with input or without input based on the arguments. And so we can go and look at the interfaces for what the interfaces for these and what those interfaces need to be. So that filter function takes a class test and a type string and returns a filter result, which we'll get to a little later when we talk about filtering and how to run subsets of the tests and how that works. The run with input and run without inputs, they take the class test and either take an input or don't, and then return a test result item, which we'll talk a little bit more about in a little bit. Test count, which takes a class test and returns an integer. The test description, which just takes the test and returns a string. And that is about it for the general interfaces for the test class. Next, we've got a test item, which is just going to hold on to a test value. And it's basically just got wrappers to call the functions that that a general test has, which is going to be needed when we want to have arrays of tests for test collections, because we can't have arrays of different types, so we have to have this kind of wrapper in the middle to be able to have arrays of different tests. And so the next level, we have two different types that extend directly from. We're gonna have two different types that extend directly from test. We've got test collection and test case. And so a test case, it's still abstract. We still won't have any values of test case explicitly floating around. But at this level now we can now be able to create implementations for the description, filter, and num cases functions. So for test case description, basically it just returns the description. If we're going to filter it, and we're just going to check if the description includes the filter string, then the result matched, and we return itself as the filter result. And then for test case and for the number of cases, well, if it's just a test case, then they're just one of them. And we'll just hold on to one of them. So now we can jump back up here to the test collection, which now also holds on to an array of test items. So a test collection holds on to multiple tests, and now we can look at the implementations for the description, filter, and num cases. So a test collection description will get an array of descriptions. So it will get the individual descriptions from all of the tests that it holds on to. And then it will also put its own description on the first line, and then indent all of the test descriptions from the tests that it holds on to. And so this is how the nice nested structure that is generated from the descriptions it is put together. Collection has its own description, and then it just includes the descriptions of the tests in its collection. And because the collection that it holds on to it still doesn't know whether it's a test case or a test collection, you can actually nest these things as far down as need be. And so you can have collections of cases, kind of a thing. And all of the description functionality still works and produces what you would expect. But let's see. We still want to look at the filter. So the filter function gets a little bit more complicated, but not by a lot. If the collections description includes the filter string, then the whole collection matches, and it can return itself as the whole collection is what it's going to return. Otherwise, it's going to check the individual tests. It's going to try and filter the individual tests that it contains. And if any of those matched, then it's going to create a new collection with just the matching tests and return that as the result of filtering. But if none of them match, then it's just going to say that none of them matched and not return anything. And finally, for the number of cases in a collection, it's just the sum of the number of cases in the individual tests that it's holding on to, which is pretty straightforward and kind of what you would expect. Alright, let's jump back up to... Now we can kind of go on to the specific test types that actually end up floating around in here and actually have values. So a simple test case is a test case that just has a pointer to a simple test. And so that simple test interface is just a function that takes no arguments and returns a result t. So a simple test just holds on to a pointer to one of those functions. And now we can start to look at how is it going to run the tests. So now we have an implementations for those. So simple test case, run with input. So if you give an input to a test case that doesn't need one, well, it's going to accept that as an input argument, but then it's just going to run itself without the argument, without the input. And so in order to run a test case, it needs to return a test result item, which a result item just holds on to a test result. And so a test result, so this is going to be a test case result, which is the description of the test and the result of running the test. So at this point we should look at what are those types. So we've got individual result and result. So a result holds on to an array of individual results. So an individual result is what you're going to get. You're going to get one of these per assertion message. But a result is going to hold on to potentially multiple of those. So all of the assertion functions actually return a result t type, but the one that they return will at that point only be holding on to one individual result. And then when you use the AND operator to combine them, it's just going to combine those results. And so a test result is an abstract type that just holds on to a description, but then we have two possible implementations of a test result. We've also got this intermediate test result item type, which is just a wrapper around that class test result, and has functions defined that are the same as the functions for the test result, just as a kind of a wrapper so that we can have arrays of these. And so a test case result just holds on to a single result, and it's also going to have that description, which was defined on the base class. Where a test collection result will hold on to an array of test results, and we can look at the all of the functions defined on the test result in a little while. But basically, running a test case is going to result in a test case result, but wrapped up in one of these test result items. And so you can kind of guess that running a test collection is going to result in a test collection result, but again, it's going to be wrapped up in one of these test result items. So now we've looked at the simple test case. Well, an input test case is a test case that holds on to an input test. And an input test is a function that takes a class input and returns a result. So this is going to be, for example, for when you have generated inputs, or the transformed inputs if you're going through that workflow. And so then we can see what's going to happen, how is it going to run that test. So if it's given an input, it just passes it along to, if it's given an input, it just passes that along to the test because the test needs an input, and then creates a test case result out of that with its own description. If it's not given an input, the result is fail, no input provided, but it's still going to create a test case result with the description. But since it couldn't run the test, it's just going to say fail, you forgot to provide input. And so you can kind of start to see that this framework has been developed with the idea of really attempting to avoid having seg faults or runtime errors which would actually crash running the test suite. Because if the test suite crashes, then I can't provide you with information about what went wrong. So to the extent possible, we try and kind of avoid any runtime errors in the tests, so that we can get as much input, feedback as possible, even if the tests fail. And so we can even then still try and run all of the tests, even if some of them fail. It won't necessarily stop the first time a test fails. It will be able to report all of the tests that fail. And so the next example we've got is a test case with examples. So this one's going to also hold on to an input test, but it's also going to hold on to an array of examples. And so now we can see, what does it do if you give this test case an input? Well, it doesn't do anything with it. It just runs itself. It ignores the input because it's already got some of its own input. So if you run it without input, it's going to go through each of the examples and combine the results of running it with the next example. And then it's going to return a test case result with the results of running all of the tests and its own description. So now we've made it down to test case with generator. So if you're going to be generating, it's going to hold on to that generator that's going to be used to generate the random test. And so now we'll go and look at how that gets done. So if you try and give this one an input, again, it's just going to ignore it because it's already got its own input. And so this one gets fun. It's for however many generator tests it's supposed to run. It's going to call the generator to get a value, run the test with that input, and if that test fails, it's going to exit. And so if we made it through all of the tests, then we're not actually going to report any of the results of running those tests. We're just going to say that it succeeded after however many tests were run. So we create a succeeding result and the description, and just return the test case result. However, if one of these failed, we're going to jump down into here, and we're going to call the shrink function from the generator with that generated value to get a simpler value. If that's the simplest possible value, then we're still gonna go ahead and run the test with that simpler value. And if that passed, then the simplest value causing failure was the previous result. Otherwise, it fails with the simplest possible example, which is the result of running it with that value. If it's not the simplest possible value, we again run the test, and if the new result passed, then the previous result is the simplest one that causes a failure, and then we can return. Otherwise, we're going to hold on to the new result as the previous result and generate we're going to use that as our we're going to use the simpler value as our generated value, so that the next time around we can shrink it. And so that's how the random tests, or the generated tests, are actually run. And so that's all of the possible test cases. And so now we can look at the test collections. So a simple test collection doesn't have anything other than what the test collection itself provides, which is just an array of test items. And so let's look at how that gets run. So if a simple test collection gets run with input, it's just going to ignore the input, because as far as the simple test collection is concerned, all of the cases it's got don't actually need the input. So it's just going to run itself without the input, which just involves going through all of the tests that it holds on to, running them, collecting them into an array of results, and creating a test collection result with those results and its description. Next, we have a test collection with input. So if we gave our test collection an input value, let's look at how that gets run. Test collection with input run with input. Well, it's got its own input already, so it's going to ignore it and just run itself without the input. And so in those cases, in order to run itself, it's just going to go again through each of its test cases, each of the tests that it holds on to, run them with its own input, with the input that it's already holding on to, collect them all together, and return a test collection result. Now we're on to a transforming test collection. which holds on to a transforming procedure, which we've looked at, which takes a class input as an input and returns a transformed as an output. And we'll look at how that's going to be run. So let's look at how it's going to be run if it's not given an input. Again, this collection, it needs an input. So if you don't give it one, it's going to fail with the no input provided. But if you do give it an input, what it's going to do is it's going to call the transformer function with that input. And then if that transformed input was a failure, then we're going to use that failure from the transforming function as and create a test case result. A test case result, because at that point we don't have a collection of results because just the transformation failed. But if that succeeded, then it's going to go through each of the tests that it holds on to and run each of the tests with the transformed input and collect those into a list of results and create a collection result as its result. And so that's all of the possible tests that can exist and how they're run. Next we can look at what are we going to do with the results once we've finally run them. So if we have a test case result, if we have a test result, there are some things that we're going to want to know. We're going to know how many assertions were made, how many test cases were there, how many of them failed, how many of the assertions failed, how many of the cases failed, did this test pass, and descriptions in the case of failure, or if we want all of the descriptions. And so the test result item is just a thin wrapper, so it's just going to call whichever of the test case result or test collection results. So let's look at the implementation of the test case result functions. So, test case result. So the failure description is if this test case passed, then the failure description should just be empty, and so it's just going to return an empty string. If it didn't pass, then it's going to give its description and the failure descriptions from its result, which we can take a look at in a little bit. If we need to know the number of assertions, we're just going to ask the result how many assertions were there. If we want to know how many cases, well, this is a test case result, so there's only one of them. And then if we want to know the number of failing asserts, well, we'll ask the result how many failing assertions there were. If we want to know the number of failing cases, well, if this case passed, then the number of failing cases is 0, otherwise it's 1, because there's only one result, or there's only one test case. And if we want to know if this case passed, we'll just ask the result if it passed. And then the test case result verbose description is just all of the result verbose description along with its own description. So let's go and look at the result functions. So number of asserts and failing assertions and all of that. So let's start with result number of asserts. So the result number of asserts is just the size of the array of the individual results that it's holding on to. That's how many assertions were made. If we want to know how many of those assertions failed, it's however many didn't pass. So it's got an array of results, which Each individual result says whether or not it passed. So the number of failing assertions is just however many of those didn't pass. And the result itself passed if all of the results passed. And the result verbose description is for each individual result, we do a verbose description and then join them together with new lines. And then the result failure description is the same. However, the failure descriptions will likely be empty if that assertion actually passed. So we'll go look at the individual results functions. Too far. Test result. Right. So the individual result failure description. So the individual result failure description is if it passed, well, that should just be empty. If it failed, we're also going to check whether or not we should colorize this, which is how we get the red and green. So these assertions are marked with green since they passed, but if there are any that fail, they'll be marked with red. And so that's what this does, is these codes have the terminal color this in red and then turn off the color. And so if we're not colorizing things, then it's just the message from that assertion itself. And then the individual result verbose description is if we're going to colorize it, then we need to know whether it passed or failed, so we know which color to make it. Otherwise, we just need the message itself. And so now we can go back to, we hadn't looked at the test collection results yet. But you can kind of probably already guess where this is going. The failure description is if the collection passed, then the description should be empty. Otherwise, it's going to be the individual descriptions and put them together with its own description. The number of asserts is just the sum of the number of asserts from each of the individual tests. Same with number of cases, number of failing, and asserts and number of failing cases. We're just going to sum up the however many for each of the individual tests. And a test collection passed if all of its tests passed. And then the verbose description is the verbose descriptions from all of the individual tests combined with its own description. And so that's basically the gist of how all of this stuff kind of works together from top to bottom. And so you can kind of then we'll go look at the run function, and then you can kind of see how that works. So this is basically where the framework is going to start. It's going to be given the entire suite of tests. It's going to go get the command line options. If filter string is given, it needs to do the filter. So it's going to do the filter. It's going to filter the tests. If that filter matched, then it's got some tests that it can run. Otherwise, it's gonna exit with an error because it didn't find any matching tests. But if it didn't need to filter, then the tests it's going to run is just all of the tests. It's going to say it's about to run the test. If you didn't tell it to be quiet, it's going to output the descriptions of all of the tests. And it's also going to say how many tests is it about to run. We're going to time how long the tests take. So we need to call call CPU time for start and end. But in the middle, we're going to run the tests. And we don't have any input, so we're just saying tests run. If it passed, it's going to say everything passed. It's going to say how long it took with 6 decimals of precision. And if you told it to be verbose, then it's going to go ahead and print out the descriptions. Otherwise, it's just going to say how many tests were there and how many assertions were there. And we've now seen how does it figure out how many cases of assertions there were. If it failed, then it's going to say it failed. Again, say how long it took. And if you told it to be verbose, then it's going to print the verbose descriptions, which is going to include both the passing and failing descriptions. Otherwise, it's just going to print the failing results. And then it's going to tell you how many cases of the total failed and how many of the assertions of the total failed. And going to exit with an error code if there was a failure. And so that's the gist of how all of this works. And so now we can start to take a look at how might you actually even be able to extend this without having to actually modify the framework itself. And so now we can start to look at the succeed and fail functions and the assertions. So we can let's start with the fail and see how that works. So fail can take either a character or a string. So we'll look at the string. Basically what all fail does is it takes that message, allocates an individual result with that message where passed is false. And succeed is exactly the same, but instead of false it says true. So they just hold on to that string and whether or not that specific assertion passed or failed. And now we can go and look at the assert functions. We'll look at the simplest one, which is just assert that. And again, these assertions will take no message, one message, or 2 messages. And either of them can be characters or strings in any combination. And so the gist is it will just end up calling with both messages. So if you say assert that with no message, it just gives empty messages. If you call it with one message, then it just gives the same message for both messages. And so the actual logic ends up in just one place. So the assert that just says if the condition given is true, then the result is just succeed with user message, which is the given success message, and this is just a standard that success message, which is just defined as a constant up here at the top. It's just that success was true, right? So as you can see, even the most basic assert actually calls succeed or fail. And we'll go back and look at that just to show you. Is it just going to call succeed or fail with the appropriate messages? And in fact, the next more complicated, which would be something like assert empty. So let's go look at assert empty, which is just going to make sure that a string is empty. And these are in alphabetical order, so scrolling. There we go. Assert empty with messages. Which is going to take possibly 3 strings. So there we go. So if the string equals the empty string, then succeed with user message, empty success message, and the success message, or make empty failure message. And so this is where the different messages that actually come from the assertions are start to be built up. Is this make empty failure message actually starts to build the strings that are reported as the results. And so all of these that are used to make the messages are actually made public, including the with user message. So it is actually possible to write your own assertions that still can use the built-in routines to construct those messages and include a user message and still end up with the same formatting and just use the fail or succeed routines to generate the results. And so it's actually possible to make custom assertions for types that you define without having to really make any modifications to the vegetables framework. And in fact, I have an example of where in a library where I've done just that. So in my quantities for Fortran library, I've actually made custom assertion routines for checking these quantities for equality. So these are meant to be. So this library is meant to be values with units associated with them. So in a simplest case, we'd have something like a length. But I've actually provided the same assert functions that you would have for double precision: assert equals within absolute, and assert equals within relative. Now we can look at how those are put together. They're almost identical to the assertions in vegetables, in that if expected equals actual, then the result is succeed with user message. Again, those come from vegetables. Make equals success message, again from vegetables, just needs a string, and so this length type knows how to turn itself into a string, and so I'll just use basically just using the built-in message construction functions from vegetables to write my own assertion routines. So I believe that is the gist and covers just about every way that you might want to use vegetables, how it works under the hood, and how you can even extend it to work with your own types to make your own custom assertions. Thanks for watching.